All right, so today we're in section 4.1. We're working on some prime factorization. So section 4.1 on page 157. All right, should have already written down some of these terms, but let's just go over them. A factor is a number that is evenly divisible by another number. So somebody give me some factors of 12. What are some factors of 12? Numbers that can evenly go into. Dylan? 3, 4, 6, 2, and then, of course, 1 and 12. Those are all factors because they can evenly go into 12. Now, a prime number is a number whose only factors are 1 and the number itself. Nothing else can evenly go into that number. A composite number has other factors other than 1 and the number itself. All right, so when we're writing the factors of a number, we're going to start in chronological order. So we always start with the number 1. 1 times 36. Is 2 divisible by 36? Okay, how many times? 2 times what? 2 times 18. Very good. What about 3? 3 times 12. Very good. Is 36. What about 4? 4 times 9 is 36. What about 5? Can't, so I'm going to skip it. What about 6? 6 times 6. What about 7? What about 8? What about 9? 9 times 4. But have I already written that? Yes. Okay, 9 times 4 and 4 times 9 is the same thing. So once I start seeing them repeat, I know that I have written all my factors. I don't have to write it twice. And now I'm ready to list my factors. I list them in chronological order. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. And now I have listed all of the factors of the number 36. All right, I want you to do the same thing for 72. All right, so for 72, 1 and 72, 2 and 36, 3 and 24, 4 and, no, 4 and 18, 5, 6, 6 and 12, 7, what about 8? 8 and 9, what about 9? 9 and 8, so am I done? Yep, I'm done because that's the same thing, so those are done, and then I just list them out. 72, I've got 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. All right, so listing factors. Okay, so now we need to tell whether or not the number is prime or composite. Well, we do that by asking ourselves, are there any other factors that can go into the number besides 1 in the number itself? So any other factors of 81? 9. Okay, so that right there proves it's composite. But any other factors? I've got 3, 27. All right, so I'm going to say composite. You can abbreviate because 3 is a factor. Now, could you say 9 is a factor? Yep. Could you say 27 is a factor? Exactly. All right, so it doesn't necessarily have to be 3, but you're going to list me at least one factor. So that proves it right there. There's other factors for 81 other than 1 and 81. Now, what about 17? Prime or composite? You're going to say prime because the only factors, 1 and 17 and 17 are the only factors. All right. Now I want you to do 51 and 120, prime or composite. All right, so 51, prime or composite? Nope. It is composite. Anybody know what the factor is? 3 or 17. All right, because 3 is a factor. So it may look like it's prime. 3 is a factor. It might not necessarily be prime, though. Now, anybody know how I can tell if, like, say, a really big number like let's say 400 and 56. How can I know that this number is divisible by 3? Anybody know how I can tell? Dylan?
Look at the last number.
Nope, not the last number.
The last two.
Alex?
You can add all the numbers.
Yes, you can add all the digits together. What's 4 plus 5?
9.
What's 9 plus 6? 15. Since 15 is divisible by 3, I know that that number is going to be divisible by 3. That's just a little shortcut. All right, now for 120, is 120 prime or composite? It is composite because what do I know for sure is one of its factors? Because 2 is a factor. Now, I mean, there's a ton of numbers that are factors for 120. 2, 5, 6, 10, 12. All right, and the list goes on. So why? All right, so is it prime or composite and why? You have a section like this on your homework tonight. All right, now in example 3, we're using a factor tree to now we're not just listing factors like we were in example 1. Now we're doing the prime factorization. So all of our factors have to be prime. They all have to be prime. So what are two numbers that can be multiplied together to equal 54? 6 and 9. 6 times 9. Well, we'll use a dot. 6 times 9. But is this the prime factorization? Are these prime factors? No, they can still be broken down more. What can I break 6 down into? 2 times 3. What can I break 9 down into? 3 times 3. All right, make sure you have the multiplication signs between each number. Because here's what I'm saying. I'm saying that all these numbers multiplied together, they're going to equal my original number. Well, what's 2 times 3? What's 6 times 3? What's 18 times 3? 54. Okay? So I'm not changing the value of this number at all. All I'm doing is breaking it down into its prime factors. Everybody agree all those numbers are prime, right? But that's not how we write our prime factorization. Do you see any of these numbers that are repeated multiplication? It's the same number repeating? Which number? 3. And how many times is it repeating? 3. So I'm going to write it as a power. 54, prime factorization of 54 is 2 times 3 to the third power. I write it to the third power because 3 is being repeated 3 times in my prime factorization. All right, I want you to do 48. All right, what two numbers can be multiplied to equal 48?
6 times 8.
Okay, 6 times 8. Anybody use a different combination? Caleb? 2 times 24. Okay. Now, if you use 2 times 24, one side of your factor tree is going to be pretty heavy, and then you're just going to have to bring the 2 down, but you'll still get the right answer. I like to have a pretty even distribution. So 6 times 8, you could do 4 times 12. Anybody do 4 times 12? Okay. But it doesn't matter because you should still get to the right answer no matter what numbers you start with. We break 6 times 8 down to 2 times 3 and 4 times 2. All right, and I'm done? Why not? Because 4 is not prime. I still need to break 4 down to 2 times 2. And then I just bring my other prime numbers down. 2 times 3 times 2 times 2 times 2. Okay? Do I have any repeated multiplication here? Oh, yeah. 2 to the
Fourth power.
times 3. Okay, who got it right? 2 to the 4th times 3? Did you get it right? Okay, did you just not finish? Okay. All right, now, factor trees are one of the 2 ways that I can do prime factorization. Now, on your quiz and test, I don't care if you use factor trees or the other method I'm about to teach you, which is upside down division. You can use either method. Now, here's where upside down division is easier. It takes less mental effort to do upside down division because you are dividing by prime numbers. Now, take 612 for example. All right, it's going to take you some mental effort to find 2 balanced numbers that equal 612, right? Because if I do 2 and 306, that doesn't really help me that much. Do you agree?
Yes, ma'am.
Okay, so 612, when I get to numbers that big, my factor trees for 1 are going to be really large. And then for 2, it takes more mental effort to figure out numbers that multiply together to equal really big numbers. So here's what you can do with upside down division. You divide by a prime number that goes evenly into that number. Well, if it's an even number, what's a prime number? Yeah, 2. So we can just keep halving it until it becomes an odd number. So 2 goes into 144 72 times. Is 72 even? Yeah. So I can divide it by 2 again. 2 goes into 72 how many times? 36. Is 36 an even number? So I can divide it by 2 again. 2 goes into 36 18 times. I can divide by 2 again. Okay, now it's 9. What's a prime number that goes into 9? 3. And now once I end up with a prime number in the very bottom, I know that I have completed my upside down division. Now I need to go back and check, are all of the numbers on the outside prime numbers? Are they all prime? Yes, they are. So I'm ready to list my prime factorization of 144 is 2 to the what? 2 to the 4th power times 3 to the 2nd power. Final answer. All right, I want you to use upside down division to do the prime factorization for 612. Okay, so 612 is even, so 2 is an easy starting point. 306, 2, 153. All right, now 2 can't go into it, but 3 can. And how many times? And then 3 can again. And then 17 is prime, so I'm done. And 612 equals 2 squared. We always start with the lowest. Times 3 squared times 17. Okay? All right, and that's how you do upside down division. All right, last but not least, we're going to tell whether or not a solution is prime or composite. So what we're doing is we're substituting in the value for the variable. Go ahead and make that substitution and solve. And what do you get? All right, so what's 3 times 6 plus 1? 19. Is 19 a prime or composite number? It's prime. So you say 19 and prime. Okay? I want you to solve the next one. R to the 3rd plus 17 when R equals 4. So what's 4 to the 3rd? 64. What's 64 plus 17? 81. It's 81 prime or composite? Whoa. It's composite. What's its factor? 9. Okay. Any other factor other than 1 and 81, it makes it composite. All right. And if you understand that, that's everything you need to know for 4.1.